Hey guys, and welcome to All About Studies. So this is Harshil Shinde, your physics teacher. And last time we learned about conductors, insulators, and types of electricity, that is static and current. So this time we are going to learn a very interesting topic, that is electric potential and potential difference. So these are two different topics, and step by step we are going to learn them. So let's get started. So first is electric potential. Let me write it for you. Electric electric potential. Now what is electric potential, guys? Do you have any idea? Well, okay, if you don't have, it's just fine. I'll tell you, I'll teach you how what is electric potential. So when very small electric charge, it is a very small electric charge. It's a positive electric charge. You can also call this a test charge because obviously it has been used for testing purposes. So as an electric test charge is kept in an electric field, in any electric field for that matter, and there is one more charge. There's another charge. It is a negative charge, for instance. Okay, so this negative charge will put a force of attraction on this positive charge. I mean, it will this negative charge will pull positive charge towards it, and there will be a force of attraction on the small positive test charge. So the work done, so due to this there will be a motion in the electric charge, that is this will move towards here, or probably here. It will go from here to here. Okay, so due to this there is some energy involved, or there is some work done by this charge. By this charge there is some work done to bring this positive charge from this place, from this position to this position. Now what happens in an electric potential is that this test charge is present in infinity. I mean, anywhere in this whole universe. And as we know, universe is such a big ocean. Actually, it's not an ocean, but yeah, it's a really big thing. And in this whole universe there is a small positive test charge present there, and this negative charge will pull from infinity to a particular point near it. So we can say that electric potential refers to the work done, refers to a work done which brings, or to be very because we are all are studying science, so we must use science terminology. So it refers to a work done wherein or which a positive test charge, right, a positive test charge, this one, positive test charge is brought from infinity, wait a second, okay, is brought from infinity to a point, to a point. So as it is quite clear by this definition that electric potential refers to the work done, the amount of work done, which by which a positive test charge, small positive, this one, is been brought from infinity, or in any where in any position in this huge infinity to a particular point. Okay, and this potential, it is denoted by a symbol V. What is now you would be thinking, what is V and all these symbols? Okay, it's fine. If you don't know about this, it's completely fine. I am going to teach you. Now what is V? So V refers to a volt. We have heard this volt or voltage, wherein most of the appliances that we use in our daily lives contain this 220 volt, this reading. So this is voltage electric potential, or potential difference, which we are going to learn right now, later in this video. So volt is equal to 1 volt. Like, what is 1 volt? So 1 volt means the amount of work done, amount of work done is 1 joule. 1 joule. Now what is joule? So joule is the SI unit for work done, wherein if you put some certain amount of work done in doing a particular task, then the amount of work done you have invested is called as 1 joule, is read by joule. So 1 joule, wherein the amount of work done is 1 joule, and the unit positive charge, well, this one, unit positive charge is 1 unit. Well, the reading, I mean, the reading of the charge present in a unit positive charge is 1 unit from infinity to a point. So I hope it's quite clear. Once again, I'll revisit on this topic that electric potential refers to a work done in which, wherein a positive test charge, very small positive test charge, is brought from infinity to a particular point, or to that point, wherein in NCRT it is written as to that point, but for our understanding, we you must remember as up to a point. Well, that's also completely fine, and it is denoted by a symbol V, wherein V stands for volt. And what is 1 volt? So volt 1 volt is equal to the amount of work done, is 1 joule, and a unit positive test charge, the amount of charge present in a unit positive charge is 1 unit, and from where it is brought, from infinity to a particular point, which is written in the definition. Okay, so let's move ahead to a topic which is quite similar to it, that is potential difference. Potential difference. Potential difference. Okay, potential difference. Let me take another sketch pen. Yeah. So what is potential difference? So as we know that electric potential stands for, refers to a work done from positive, wherein a positive test charge is brought from infinity to a particular point. Now in potential difference, things get a bit, a bit more easier, a bit more understandable, and also a bit more realistic. Okay, so here what happens is that let's take another the same positive test charge which we have seen here. It's a big one. Okay, so this is the positive unit test charge, and this is a negative charge. It's a negative charge. Okay, so here we have to, so as we know that this electric negative charge will apply a force of attraction to this positive test charge. Okay, so it will pull towards it. So as we know that this position is A, let's take this position as A. Now by as we know that it is pulling towards it, so it will bring, let's assume that this charge will come at here at this position. So the there is a as you can see that there is a change of position. So earlier it was at A, position A, then it came to B. So as you can see that there is a displacement, or displacement covered from A to B. And so what can be inferred from this whole diagram? So it can be assumed, it can be inferred that the amount of work done that this charge, that is this negative test charge, has put on this positive test charge to bring from A to B is called as potential difference. So let me write here for you. So what is potential difference? The definition, which I think is really very important for your subject to term to board examinations. Let me write it for you so that things get a bit more easier. So the electric potential is, it is defined as work done. Just a second. Defined as the work done in which a positive positive test charge is moved or brought. You can use any word. Moved is a bit of sophisticated word, wherein in which a positive test charge is moved from one position to another. So you might be thinking that this definition is a bit ambiguous, not clear, it's a bit ambiguous and we can't understand it in a proper way. Okay, don't worry, I'll explain it each and everything. So this is a negative charge and this is a positive test charge. This negative charge will put a force of attraction to this positive charge, because as we have learned that uh, like charges repel and unlike charges attract each other. So this positive test charge will attract towards this negative one and it will move towards it. So by this there is a change of position here. Earlier it was at A, now it displaced to the position B. So the work done put on by this negative charge by bringing this positive test charge from A to B, from point A to point B. Well, it is this work done is defined as the potential difference. Simple. This is very easy. I hope you have got the concept. So, let's write its formula. So, potential difference, I'll write it short as PD. PD is equal to work done, the amount of work done in bringing this positive test charge from one point A to point B, work done upon quantity of charge move. So there might be a quantity of charge. It, I mean, the amount of charge that this electron or proton may contain. Okay, so this work done can be denoted as W, and quantity of charge is denoted by Q, and this PD is denoted as V, as we have seen here also. Just a second, as we have seen that it is denoted by V, so the potential difference is also denoted by V. Both electric potential and potential difference are being denoted by V. So V is equal to W by Q, wherein W is the work done and Q is the quantity of charge, which is measured in coulombs. If you don't know about what is coulombs or the quantity of test charge or charge, don't worry. You can refer my earlier video, which contains the whole wherein I have explained what is charge, what is quantity of charge, everything. So picture the picture gets a bit more clear after watching this video. Okay. So as you can see that this is the formula. You have to remember this, as numericals can be asked from this formula. Okay. So moving on to the next page. Wait, I'll change it for you. Just a second. Okay, writing the formula again. So V is equal to W by Q. What is V? V is the potential difference or the electric potential. But here we have to remember it as potential difference. Potential difference is equal to work done upon Q is the quantity of charge moved. So V is equal to volt, the SI unit of potential difference. I am writing as PD, but when you are remembering the formula as well as the content, you have to remember, you have to make it as PD, that is potential difference. Don't remember it as PD. Don't, and also don't write in exam PD, right. You have to write the whole potential difference while you are performing the numericals. Okay. So SI unit of PD is volt, And what is 1 volt? Now this is the representation of 1 volt in the form of this formula. Okay, so 1 volt is the amount of work done. Now here, what is the amount of work done? So 1 joule. Now what is joule? The joule is the SI unit of work done. And uh, Q, yeah, and the charge moved, or the quantity of charge moved is 1 coulomb. Wait. Yeah, 1 coulomb. Wait, the spelling is a bit wrong. I'm sorry. Okay. Okay, so what is 1 volt? So 1 volt, you can remember it as 1 volt is equal to the amount of work, where 1 volt is the amount of work done, which is 1 joule, and 1 coulomb is the quantity of charge moved. So this is the representation which you can remember. It's really, really very important. Okay, so now the device, well, how we can measure potential difference? So we know the formula, we know the representation, we also know the definition, but how we can measure the potential difference of a electrical appliance? So it can be easily done by a device called as voltmeter. So potential difference can be measured by voltmeter. Okay, it can be measured by voltmeter, and yeah, and it is always connected in parallel. Now what is parallel? We will definitely learn in a later video, because it is there in this chapter, and also in your term 2 syllabus of the term 2 board exams. So, and voltmeter are always connected in parallel. For the time being, you have to remember it as voltmeter are connected in parallel. You don't have to now right now go into the detail that what is parallel and what is series. I'll definitely cover this everything, parallel, series, what are the types of circuit, in my later videos. So for that you have to subscribe to the channel. And okay, so let's move ahead. So this voltmeter, there is a tendency of this voltmeter that it has a very high resistance. This voltmeter has a very high resistance, and due to this high resistance, it doesn't take any current from the circuit. There are, you might know that, when we put any appliances or any wires for that matter in a circuit, then there is a some amount of resistance in them as well. Like if you put a wire, then there is a resistance of that wire as well. Even though there is a small amount of resistance, but still there is. So this has a very, very high resistance, and due to this, the current it takes is negligible. Current it takes is negligible. It doesn't take any current, and volt is also known as voltage. So this is for your general knowledge. Volt is also known as voltage, the larger form of this word. So guys, this is about the voltmeter, then this formula of potential difference and electric potential. So I hope you really like this video. Make sure to like this video, share it with your friends so that they can also educate, and also subscribe to All About Studies for more such informative videos. Till then, thank you so much for watching. Bye bye.